Yeah, hot water pumps are designed to handle hot water, and they sometimes have to even make amends for that and have to bring outside cool water in to cool the packing area or the stuffing box area of the pump. That does sometimes have to occur if it's hot water. And we get into pumpage of things like the hot oils in those like the French fry plants. They're pumping hot oils at 450 degrees all the time. Very specialized pumps at that point. You know, they have an external cooling system on them because they're having to move a very specialized product. But for irrigation water, we generally don't have to worry about the temperatures, but sometimes we do run into it in where we have residual wastewater, and it can be pretty hot coming out of some of these processes. And you never know when you work in the pump industry what you're going to work on next. You know, in this country, if you work for a pump sales, if your irrigation company does pump sales, you might end up working a lot of the time in food processing. Lots and lots of pumps in food processing in this part of the country. And gosh, you may be pumping anything under the sun. I mean, you can pump awful big product through these things. They pump, you could be working for the Department of Fisheries and be pumping trout, you know, or salmon, baby salmon or whatever. That they suck all those up through pumps. They don't have a whole bunch of veins. They just have one big vein in the impeller. That fish just gets spun once as it's coming through there. It'd make them a little dizzy, not too dizzy. But big openings and plenty of room for them. You can pump live fish, no problem. You could pump watermelons if you wanted to, if you got a big enough pump, you know. All this food processing, they float most of the product as often as they can because it doesn't bruise it. So they can keep it in water, and it's a great method of moving product through a food processing operation. So that's a very viable thing. Now we got three styles of pumps basically that we use in irrigation, and then there's a fourth that's listed for very small type systems. Well, I'm going to hold off on that a minute. I want to talk about this pump curve just a little bit more. We can go ahead and pinpoint a couple of spots in here just to see if you can read this curve. So let me give you a couple of conditions, and then I want you guys to tell me the rest of the stuff about it. Let's say we want to run at 1500 GPM, and we want to be at 125 feet of total head. Tell me what the efficiency is of that pump. So what we do is we come into this curve, we go 1500 and go straight up, 125 feet straight across, and where they intercept is a point. And it's just under 86%, maybe 85.5% efficiency. Everybody with me? You found a point where 1500 and 125 intercept. What is the horsepower at that point? So we keep that point.
53.25 horsepower.
And we find that we're between 50 and 60 horsepower. And it's somewhere, maybe 54, probably about 54 horsepower. You interpolate between the lines. And you could actually take a ruler and scale it and get very accurate.
I was about to say, can they get exact with that?
Well, you can, because you can plug it into, let's see what it's going to be. What is our horsepower going to be? Let's just calculate it. So our GPM's 1500. Our TDH is 125. We're divided by 3960. And the efficiency was about 85.5. We'll say 85.5. And we'll just see what that brake horsepower turns out to be. Yeah, you use point, you don't use the percent, you use the efficiency as 0.855. It comes out to about, what, 55.3 horsepower. So our 55 was pretty close. We guessed about 55 and ended up being 55.3 calculated. Now the calculated horsepower would be more accurate. This would be the exact draw right here. So, you know, we're interpolating on our graph. Over here we can get a true calculation.